Hello, ladies and gentlemen. Thank you for coming today. I'm Iryna Bodnar and I'm looking forward to talking with you today about prediction of cervical cancer using machine learning. The main goal of the project is improving the diagnosis of diseases in women and the work of doctors in this field. Besides, we can get an immediate diagnosis based on information and analysis of the patient. Why this project is so important for us? The average age of a woman diagnosed with cancer of the cervix is 50. More than one-third of new cervical cancer diagnoses are in women between 20 and 44 years old. About 80% of all cervical cancer diagnoses are in women younger than 65, although it is the most preventable type of cancer. Each year, cervical cancer kills about 300,000 women worldwide. Let's now turn to research method of machine learning. The algorithm that I used in this work is random forest, an ensemble learning method for classification, regression, and other tasks that operate by constructing a multitude of decision trees, a training time, and outputting the class that is the model of the classes, classification or mean prediction, regression of the individual trees. Random forests are a way of averaging multiple deep decision trees, trained on different parts of the same training set, with the goal of reducing the variance. This comes at the expense of a small increase in the bias and some loss of interpretability, but generally greatly boosts the performance in the final model. The main advantages of this method runs efficiently on large databases, handles thousands of input variables without variable deletion, generates an internal unbiased estimate of the generalization error as the forest building progresses, provides effective method for estimating missing data, provides methods for balancing error in class population unbalanced data sets. Generated forests can be saved for future use on either data. Prototypes are computed that give information about the relation between the variables and the classification. Computes proximities between pairs of cases that can be used in clustering, locating outliers, or give interesting views of the data. Capabilities of the above can be extended to unlabeled data, leading to unsupervised clustering, data views, and outlier detection accuracy. The main disadvantages of this algorithm: random forests have been observed to overfit for some datasets with noisy classification regression tasks. Unlike decision trees, the classification made by random forests are difficult for humans to interpret. For data including categorical variables with different number of levels, random forests are biased in favor of these attributes with more levels. Therefore, the variable importance scores from random forests are not reliable for this type of data. Methods such as partial permutation were used to solve the problem. If the data contain groups of correlated features of similar relevance for the output, then smaller groups are favored over larger groups. Turning our attention now to my dataset. There are 36 different indicators that make it possible to evaluate the risk of the disease. The main ones are DX cancer, STD's number of diagnoses, number of pregnancies, first sexual intercourse, cytology, biopsy. I'd now like to move on to the next part, research tool. The programming language used to perform the task is Python. Advantages of Python in machine learning: great library system, low entry fence, flexibility, platform independence, readability. To simplify the work, we use the following built-in Python libraries: NumPy, Pandas, Seaborn. Besides, I used Matplotlib and scikit-learn. Scikit-learn is probably the most useful library for machine learning in Python. The scikit-learn library contains a lot of efficient tools for machine learning and statistical modeling, including classification, regression, clustering, and dimensionality reduction. All of this leads me to my next point, which is description of the control example. First step is exploratory data analysis. This is a step that we should always perform before trying to fit a model to the data, as this step will often lead to important insights about our data. From the above graphs of distribution of variables, it can be seen that hormonal contraceptive column has the highest number of ones, which indicate that this might be the important key feature in detection of the cervical cancer. So let us concentrate on this feature more in future analysis. The next step was to analyze the age variable to determine what age women most often face this problem. This figure shows the distribution of the number of patients relative to their age. In addition, it was found that the average age at which a diagnosis of cervical cancer is confirmed is 26.8 years. Density graphs shows that women who started sexual activity at the age of 50 to 20 years have a high chance of developing a malignant tumor due to incomplete development of the corresponding organs. Therefore, these characteristics can also be considered as a key feature in the detection of cervical cancer. Based on the distribution of data points in the scatter plot, the Schiller and biopsy tests are showing that women who are smoking for more than 5 years are having more chances of getting the tumor. The distribution of negative test results showed that an intrauterine device used for any number of years had an effect on reducing the chances of encountering cancer. I'd now like to move on to the next part, starting to build the machine learning model with the final features. There are 4 target variables in the dataset. For building the model, I have considered a new variable cervical cancer, which is the sum of the 4 target variables. That is cervical cancer. There are 4 target variables in the dataset. For building the model, I have considered to create a new variable cervical cancer, which is the sum of the 4 target variables. That is cervical cancer equal Hinselmann plus Schiller plus cytology plus biopsy, which gives 5 different values ranging from 0 to 4. These values represent the level of risk. 0 represents no risk and 4 represents higher level of risk. So the final class target variables are 0, 1, 2, 3, 4. Next, I calculated the accuracy of models created by various algorithms using the cross-checking method. The goal is to check whether the results of statistical analysis are generalized on an independent dataset. From the results obtained in the previous step, I choose the most correct algorithm for my data, namely random forest, whose accuracy is 0.944 and predicted the threat level for 3 women with different indicators. So let's see how it's work. This presentation concerns prediction of the risk of cervical cancer. The main provisions of the study, the method and means were reviewed and briefly described. At the end of this presentation, a control example is analyzed to determine the accuracy of the created model. The value of the cross-validation coefficient for the created model is 0.944, which means that the results obtained are highly accurate. That brings me to the end of my presentation. Thank you for listening.